Alright, who likes that feeling on a roller coaster when, you're shoved back into your seat because you're going so fast, or all of a sudden you slam on the brakes and you kind of flop a little forward or anything like that? Those sorts of feelings are created by acceleration. Alright, so we need to discuss what that is. So, acceleration is a change in velocity, or it could be a change in direction over time. Okay, so this equation, and actually this second version is probably the best way for you to learn this, is to know that acceleration is equal to your final velocity, so the velocity that you end at, minus your initial velocity, or v naught, and divided by time. Alright, so the F stands for final, the O stands for naught, but that just means initial velocity. Okay? So it's the change in velocity over time. So this equation, compared to the other ones we've been dealing with so far, is a little bit more complicated. Alright, you are going to have some different rules as far as rearranging it. Okay? Another thing to keep in mind, your units, because if you think about it, velocity is meters per second, and time is seconds. So if you do a velocity over time, you have meters per second, which can also be written as meters per second squared. Alright? So if you were to use this equation, in this class we don't just sit there and always just calculate acceleration. Sometimes you already know the acceleration and you want to know what velocity you're going to be at after that acceleration period of time or something like that. So other versions of the equation are available down here. Alright, I will show you how to rearrange for VF, but these just follow your general basic algebra rules. Whatever you want to move over, you have to do the opposite to get it to the other side. So if you think of, erase this, give us some more room. So if you think of starting with this equation and we want to rearrange it, alright, the first thing, and we want to rearrange for BF. So we need to move everything else out of there. So again, kind of follow your order of operations. You want to start with the multiplication and the division before you start moving subtraction and addition. Okay? So in order to get rid of the t, since we're dividing by t, the opposite of that is multiplying by t. So multiply both sides by t. Okay? So t over t gives you 1, so those cancel out. And we have AT equals VF minus V naught. Alright, so now we are subtracting V naught, so the opposite of that would be adding V naught. Okay, so plus. So you'll have AT plus V naught equals, and then, -1 plus +1 gives you 0, so these are going to cancel out. Essentially, adding the negative of a number plus that number always gives you 0, so that's how these cancel. So, and we are left with VF. And if you notice, this equation matches that equation. Alright? Now, the trickier way to rearrange this one, or the harder version to rearrange, is probably actually rearranging for t. Just keep in mind, when you're looking at this equation, the A equals VF minus VO over t, on this side, what t really is, it's not t by itself, it's 1 over t. Alright? So if you're ever trying to rearrange for something where it's in the denominator or underneath a fraction, you always have to start by getting it out of there. So you always need to multiply by it. So the first step for rearranging for this one is still multiplying by t so that we can get t out of the denominator and into the numerator. Okay? So, another thing to keep in mind, acceleration is a vector. So once again, direction matters. All right? A good rule of thumb, if you are speeding up, so your velocity is increasing, acceleration is positive. All right? If you are slowing down, your acceleration should be negative. All right? In the future, we will run into an exception to this rule, but for the most part, speeding up is positive, slowing down is negative. Another way of talking about slowing down is the word deceleration, which is essentially the opposite of acceleration, so you're slowing down. Let's start applying this a little bit. All right, so this is a simple basic problem. We are going to be solving for our acceleration. All right, so I'm actually going to make this a little smaller so that I have room to show lesser to you guys. So right here, we are given our knowns. So this is going to be our L. Our equation, so we know we have a V0, a VF, and a T. So we want to solve for A, and that's VF minus V0 over T. To solve, or to substitute, you have A equals 0 minus 10 over 5. Alright, so that's kind of like negative 10 over 5, which will give you negative 2. Alright, and then just remembering your units, this is acceleration, so it's meters per second squared. So negative 2 meters per second squared. Okay? Now if you think about it, this is going up the roller coaster. It makes sense that you'd be slowing down as you go up the roller coaster. Those of you who've gone on roller coasters, usually at the top you almost stop before you start going down. Alright, so you should, since you are slowing down, you should be getting that negative value. Alright, so now let's do the other side. Again, this is our L. This is what we know. Our equation is the same. It's A equals VF minus V0 over T. Substitute in our knowns. A is equal to 10 minus 0 over 2 seconds. That's just a 0. So we're going to have 10 over 2, which is equal to 5. And if we put in our units, it's meters per second squared. Okay? And again, makes sense. We're not getting a negative value here. This is a positive 5 because we are speeding up. All right? Another problem. We have a race car accelerating at 5 meters per second squared over 12 seconds. The car's final velocity is 75 meters per second was the car's initial velocity. So this one, we have to use one of those other variations because we already have our acceleration, we have our time, and we have our final velocity. Okay? So let's do our lasso. A equals 5 meters per second squared. T equals 12 seconds. And VF equals 75 meters per second. V0 is our question. Alright, so our equation, we have A equals VF minus V0 over T. Alright, rearranging that for V0, you will have VF minus AT. Okay. So let's substitute in our knowns. V0 equals 75 minus 5 times 12, which is also 75 minus 60, which leaves you with 15. And we are solving for V0, so your units should be velocity units or meters per second. Okay? So, hopefully this makes sense to you. Like, you should initially be thinking that, oh, I'm going to get a smaller number because I know the final velocity after the acceleration occurred. So The initial velocity had to be something less. And so we have a car slamming on its brakes that decelerates at negative 10 meters per second squared. If the car was going at 45 meters per second, how long does it take for the car to stop? Okay, so let's look at some of our information. Good place to start is your numbers. Okay, so we have our acceleration equals negative 10 meters per second squared, and the car was going at 45 meters per second. That word was gives you the impression that it has changed since, so that means that's our V naught. It's 45 meters per second. All right. And our question is, how long does it take? So we want to know t. And initially, it seems like you don't have enough information, but keep an eye out for the word stop. What does that tell you that your final velocity is going to be? At stopped, you're not moving, so your velocity is 0. All right, so keep an eye out for that word stopped, or possibly from rest. Those things are going to mean 0. Okay? So our equation is A equals VF minus V naught over T. We want to know T. So T equals VF minus V naught over A. So if we substitute in our numbers, we have 0 minus 45 over negative 10. All right, which is also kind of like negative 45 over negative 10. So when we solve for that, dividing by 10, you move the decimal point over. Also note, dividing a negative number by a negative number cancels out those negatives. All right. So we're going to have 4.5, and then our units, because we're solving for time, is seconds. Good rule of thumb to keep in mind when you're solving these sorts of problems: time can never be negative. All right, never a negative number. We can't go backwards in time. So you want to look out for stuff like this where your negatives cancel out. Okay. So that's the end of the video. Make sure you do the online assignment, and I will see you in class.